Hey everyone, so we're going to talk about something that every single developer runs into. That moment when you need to level up your code from something that just works to something that's actually, professional. We're talking secure, maintainable, and well-architected APIs. Let's get into it. I want you to think about the last function you wrote. Just picture it in your head. Chances are it was trying to do more than one thing at the same time. And this right here is the root of so much technical debt, so many headaches, and so many bugs. So that brings us to the big question for today. Does your code have two different jobs that are constantly at war with each other?
All right, so let's break it down. Pretty much every piece of back-end code you write is trying to do this delicate balancing act between two very different and often conflicting jobs. We're going to call them business logic and technical plumbing.
And this slide just lays it out perfectly. On one side, you've got the business logic. This is the what. It's the whole point of your feature, right? Adding a product to a cart, checking inventory. It's the stuff that your product manager actually cares about. But then on the other side, you've got the technical logic, all the plumbing. This is the how. How do we connect to the production database? How do we load that secret API key? This stuff is absolutely essential, but it really has nothing to do with the actual idea of a shopping cart.
So what's the big deal? Why does this even matter? Well, this brings us to what we call the dependency dilemma. Because when you start mixing the what and the how inside the same piece of code, oh man, things get messy and they get messy fast. Let's look at the actual pain this causes.
When you tangle these two jobs together, you just create this whole host of problems. First off, your code becomes a nightmare to test. How are you supposed to test an add to cart function if it's hardwired to talk to your live production database? You can't. It also gets really insecure, because developers get tempted to just drop secrets and passwords right there in the code. And it becomes super brittle. If you ever want to change how you connect to the database, guess what? You've got to go find and change every single function that does it. It's a mess to read and a pain to maintain. And this little snippet of code, it says it all, doesn't it? The very first thing our add to cart function does is, well, it's not adding anything to a cart. It's playing system administrator, checking the environment to figure out which database to use. This whole if-else-else block is pure technical plumbing, and it has absolutely nothing to do with the business idea of a shopping cart. The function is already polluted before it even gets to its real job. Okay, so how do we fix this disaster? Well, the answer is a really elegant and powerful design pattern that helps us build a much better architecture. It's called Dependency Injection.
Now, don't let the fancy name scare you. The idea behind it is actually incredibly simple. Instead of having a function build its own tools, like creating its own database connection from scratch, the function just asks for the tools it needs. It declares its dependencies. Then, some other part of the system, somewhere else, is responsible for creating that tool and injecting it or providing it when the function gets called. So the function just gets what it asks for and can focus on its one true job.
Now, this might all sound a bit abstract, but if you happen to be using the Python framework FastAPI, this whole process feels like absolute magic. FastAPI gives us this little tool called Depends that makes dependency injection almost effortless. Let's see what that looks like.
So here's our add to cart function the old way, before dependency injection. You can see it's doing everything itself. It has to create the database session, do its work, and then it has to remember to close the session properly. The what, the business logic, and the how, the plumbing, are completely tangled up. And here it is after. Just look at that. Look how clean that is. The function signature now just says, hey, to do my job, I need a DB session, and it uses depends to tell FastAPI how to go get one. The body of the function now contains only pure business logic. It has no idea if it's a production database or a test database or something else entirely. It doesn't care. It just gets the tool it needs and does its job. This is that great separation we've been talking about.
Okay, so our functions are beautifully clean now. But somewhere, the dependency injector still needs to know how to build that database connection, right? It needs the URL, the password, all that stuff. So where do we store sensitive information like that? The answer is environment variables.
And this next point is, and I'm not exaggerating, one of the most important rules in all of software development. You should never, ever commit sensitive data like API keys or database URLs into your Git repository. The second you do that, that secret is compromised forever. Anyone who can see your code now has the keys to your kingdom. It is a massive security risk.
So the secure, industry-standard way to handle this is super simple. First, you create a file in your project called literally .env. Inside that file, you put your secrets, like database URL equals blah blah blah, and so on. Then, and this is the most important step, you cannot forget this, you add .env to your .gitignore file. This tells Git to completely ignore this file, to never track it, so it never leaves your machine. Then, your application code can just read these variables from the environment when it starts up. Simple.
All right, we've covered the big ideas, separating our logic using dependency injection and securing our configuration with environment variables. Now let's put all these pieces together and see what a modern, production-ready backend actually looks like in action.
For our example stack, we're going to use a couple of really fantastic tools. For the database, we'll use Neon, which is a managed, serverless PostgreSQL database. It basically handles all the boring database admin stuff for us. And then we'll use SQLModel, which is this brilliant library that acts as a bridge between our Python objects and our database tables. And this slide shows how it all fits together in these nice, clean layers. So at the very top, you've got FastAPI. It's handling the web requests. When a request comes in for our Add to Cart endpoint, FastAPI sees that the function needs a database session and uses dependency injection to provide one. That session is powered by SQLModel, which knows how to talk to our database, and at the very bottom, the database itself is running on Neon, totally secure, with its connection details loaded safely from our environment variables. See? Every single piece has one clear job. It's beautiful.
So, what's the big takeaway from all this? It's really a shift in how you think. Leveling up as a developer isn't just about learning more syntax or another library. It's about learning architecture. And like the slide says, great code isn't just about what it does. It's about what it cleanly separates. So take a look at your own projects. What two jobs is your code trying to do at once? And how can you start to pull them apart? Thanks for joining me.